Greetings and welcome, friends. Today we're going to talk about dividing polynomials because we already know how to add and subtract and multiply using various distributive techniques. Good times. But today we're going to talk about dividing. In fact, we're going to spend a couple days on dividing. We're going to learn a technique first for dividing by a monomial, and then we're going to talk about dividing by polynomials where we have to use long division. So let's start off with a nice little example here, and I'm going to paste this guy right here. Look at this thing of beauty. Dividing by a monomial. I'm going to show you a particular technique for our friend here. I'll let you guys write that down real quick, like. Quick, like quick. So, if I'm dividing this, looks like this is a 5th degree trinomial, right? Some of the highest degrees exponents, right? 5th degree trinomial divided by a quadratic monomial, right? Remember, terms are broken up by plus and or minus signs. There's no plus or minus sign down here, so this is just a single term, hence a monomial. Which, by the way, every time I see the word monomial, it makes me think of like oatmeal. It makes me think of some sort of breakfast food. Or it also makes me think of bone meal, which is from like Skyrim, which I don't know why you'd ever want to use bone meal for anything. Not even for alchemy. Oh, it might be in there too. Yeah. So anyways, if you're going to divide by a monomial, this is the technique. I guess I'll just write it this way. Divide each term by the monomial.
Oh, so you would do like the 32xy3 individually with the 4xy? Like everything's by, like, goes down?
Yeah, everything gets individually divided by that monomial. Right? Something like that. Notice that I put a minus sign between these two fractions. I could have made this plus if I left the numerator negative, but I figured it made more sense to just have a subtraction symbol there. So now I can just divide these each like it was some properties of exponents problem, right? Like if I zoom in here, I can be like, this is just like a problem we had from a few days ago, right? Where I deal with a 6/4 like I would a normal fraction, where 2 goes into 4 twice and into 6 thrice. And then with the x's, move the little guy to the big guy, and with the y's, move the little guy to the big guy. So let's see, so that first term is going to be 3 halves, x to the 3 minus 1 is 2, y to the 2 minus 1 is a 1, right? And then I'll subtract over here, and deal with this like a regular old fraction. 2 goes into 4 twice and into 18 9z's. Subtract the x's and the y. Oh, the y's actually just straight up kill each other in a knife fight. Minus 9 halves. Forgive my insensitivity for those of you who have friends who died in knife fights. My apologies. I should have been more sensitive. I don't know. Who knows? 32/4. I could reduce that like a normal frac. 4 goes into that once and into 32. Anyone know it? 8 times, because 8 times 4 is 32. 8 times 4 is dirty U. I once saw this crazy school that taught math through like weird rhymes stuff. And there was a story they had. X's cancel. And what's up? You're excused. What's up? What do you need?
So, can we just hold the phone? Go to the center one, the -9/2.
Yep.
Why is it x to the second? Yeah.
Oh, did I make an error? That's why I've got friends. That's right. Thank you, friends. Good call. Right, x to the second minus x to the first was x to the first. My likes. Thank you. Good save. So yeah, right? So this is, you guys can figure this out, right? This isn't too crazy. So this is how you divide by a monomial. Before I get into long division, though, for dividing polynomials, let's do a quick little recall problem. Just because you might not have looked at long division since you were in, say, the 4th grade, perhaps. I don't know. Recall, what if I want to divide? I guess I'll use the image here.
Oh, I remember this. So you put the 1 over the 7.
Oh, slow your roll now. Slow your roll. So, does anyone know the technique for dividing longly? Or do you know an acronym? Do you know the acronym for long division? The acronym is DMSB. And I'll use this vinculum, just like a repeating decimal, to indicate repeat those steps. That's pretty clever, I thought. Anyway, what does DMSB stand for? D is for divide, M is for multiply, S is for subtract, B is for bring down, bring it around town. So if I'm dividing 6 into 724, which by the way is what this symbol means, so 6 dividing, I almost make this look like a square root. All right, here we go. 6 divided into 724. Yeah, what's the first thing I do?
So you put a little 1 over the 7.
Why? Where'd you get 1?
Because 6 goes into 7 once.
Okay, so that was the divide step. She divided 6 into 7 and it fit once, and we write our answer up there.
The 6 under the 7.
How'd you get 6?
Because 6 is what you multiply.
Because you multiply 1 times 6 and you write that down here, right?
Oh, I thought you just write down. Yeah.
So that's
you write down it under the
6.
multiple.
Okay.
And you get 1 left over.
How'd you get 1 left over? Because you
subtracted.
subtracted.
Wow, I like this. And
All right.
1, and then you bring down the 2.
Bring it around town. I like it.
And then you know that should be 2 because 6 goes into 12 twice.
Oh, slow down. So I just want to point out we've finished 1 full lap of DMSB. And now we're going to start over again because it repeats. So she's now going to divide 6 into this instead of the 7. Okay, so we're dividing 6 into 12. So 6 goes into 12 twice, you say? So I write the 2 in this next
and then you multiply with
position.
12.
And 2 times 6 is 12, I agree.
Oh no, now you have 0.
And then subtract, I get, 0.
Then you bring down a 4, but it doesn't go in. What do you do?
Hmm.
So then you put a decimal point and you make a 0.
Well,
Right?
well, 6 goes into 4 less than once, 0 times.
Yeah. And then you put the 4.
Well, and then I could multiply, that's 0, and subtract. And if I run out of space here, I could say that 4 is my remainder, which actually, let's talk some quick vocab here first. And then we'll talk about how, if you didn't want to deal with a remainder. I'm not going to have you guys write these down, but if you want, I can show them to you later if you're interested in that. So let's see. Let me explain what's up. Quotient, all right, is the result or answer to the division, okay? This 120 would be the quotient. This was the answer I got, or part of the answer technically because I also have a remainder. So that's the quotient, all right? The dividend, whoa, settle down there, computer. The dividend, it says, is the expression being divided. What part was the dividend in this? Well, the 724 was the part that was being divided. 6 was going into 724, right? Okay, so that's the dividend. The divisor is the 6. That's the expression that is being divided into another expression. All right, so we've got so far quotient, dividend, divisor, and then the last part it says is the remainder, which is the leftover expression due to not dividing, and I put evenly in quotes, right, where I can't get 6 to go into 4 anymore. So this would have been called the remainder, okay? Just so you guys understand some of the language there. All right, and that same language is going to apply when we're dealing with polynomials. Now, but let's say I didn't want a remainder. Sometimes you can get a decimal approximation. So if you wanted, I could actually say, well, what if I just called this 724.0? And I just finished the subtract step, so I could actually bring down the 0. And how many times does 6 go into 40?
6 times.
Would you do the decimal?
Yeah, 6 times. And then I could multiply and I'd get 36.
You get another 4, so you can do
And then I'd get another 4 and I'd do it again. And I'd get another, yeah, I would end up actually getting lots and lots of 6s here. So decimally speaking, it's 120.6 is the answer. I could call this 120 with a remainder of 4 if I wanted.
You realize
What's up?
that 6 goes into 72 12 times.
Yeah, imagine this problem was truncated here. Right, imagine this was the entire problem.
You could have like skipped a step.
Well, I suppose you could. Yeah, if you said 12 and then you did 12 times 6, you would have gotten 72, and then you would have had 0 and then bring down. Yeah, you could have tried to figure out something clever like that if you wanted. Interesting technique. I like it. So here's my quotient, my remainder, stuff like that. Another way you can write your remainder, by the way, I could also write this as 120 plus 4 divided by the divisor, 4/6. All right, which that's the same as 120 and 2/3. All right. Or if you kind of mix fraction that a little bit, you could. But I'm just going to leave the plus sign there for now. So it's possible to use the remainder over the divisor. So I'll write rem over divisor. All right. Is kind of how you could also represent that. And sometimes we'll use that technique as well. So you guys remember long division a little bit from 4th grade? Maybe? Yeah, maybe. Familiar-ish? And by the way, the words I always would be likely to mix up is dividend and divisor. Also, maybe that's one of the things I should point out. If this wasn't originally given to me as with this division symbol, this is the same as 724 over 6. Okay, so this would translate into that. Okay, so if you have a fraction, for instance, the dividend is up top, the divisor's on the bottom. All right. And the divisor goes on the outside of the little weird division symbol thing. All right, so just so you're aware of that. The name of the symbol?
Yeah.
I believe it's just called a. I don't know. That's a good.
Division bracket.
I would call it a division. I guess division symbol is also this one though, huh? Interesting. Yeah, I'll have to look that up. Good question. Maybe you could look it up and add it to the comments below. Thanks.
Welcome.
So let's see. Let's do an example. So this is a trickster problem right here.
Well, that's a trickster.
Because it says simplify, but I'm talking about dividing today.
But it's a negative one.
Oh, a -1 exponent. What do I do with a -1 exponent?
Put it over.
Everything over 1.
Yeah.
Yeah, I move this downstairs, right? So this is the same as x squared plus 6x plus 8 over x plus 3. Right, so I am dividing by x plus 3. And if I want to divide this now, let's set it up. So let's see. What is the dividend?
Dividend is the x squared plus 6x plus 8.
Yep. So that's going on the inside of the division bar thing right here. And the divisor is the x plus 3 on the outside. And we're going to use exactly the same technique. I'm going to divide, multiply, subtract, bring down, repeat. Rinse and repeat. Right?
I keep doing square roots and rule.
Yeah, I know. I have such a hard time doing that. Classic. Actually, when I see some math symbols for this, sometimes like this part of it's even like curvy. It's the way it shows up on my font, which I think is interesting as well.
So I always make them with a little curvy.
Yeah, I suppose you could do the curve there if you want. Yeah. So let's divide. Now, for the divide step, here's my little tip. Divide the leading term by the leading term. Okay? So when I'm figuring out the division here, I'm going to figure out x squared divided by x. All right, that's what I mean by divide the leading term by the leading term. Okay, so let's see. 90% of the time, students answer this question wrong. What is x squared divided by x? Ooh, a lot of people say 2. Or if I ask, or maybe it depends on how I phrase it. If I ask, how many times does x go into x squared? That's when I phrase it that way. They're like, 2. And I'm like, no, it goes in x many times. All right, if you want to do a little bit of scrap work, though, on the side, you can. So you could do like x squared divided by x and be like, oh, right, oh, I'd move that upstairs and subtract, and that's x to the first. Now, let's see, where should I write this x to the first? Let me show you, give you a good tip. Don't write it here. Better yet, let's write it here.
Why?
Why? Because I'm writing it in the column that's going to have all of my x to the first buddies in it. Everything else in the rest of this column is going to be x to the firsts. So it's going to be helpful for us to keep it there, just to organize our work a little bit. All right, so that was the divide step. Good, we got that one done. Now we're multiply. All right?
Wait, this is so hard. Oh my God.
It's hard?
Really hard.
And on the multiply step, I'm going to suggest that we distribute. It's going to be important to do that. Important. So I'm going to multiply, right, this x to the first times the x plus 3. And I'm going to write that right down here. Right, remember that's what we did up here? Right, I multiplied the 1 times the 6, and I wrote it down there. Remember? Yep. So let's do the same thing on this problem. So x times x is x squared. X times 3 is 3x. Because we distribute.
No. Why is that x to the first right there?
This?
Yeah, that thing.
That's what we got as the result of division. All right. So let's see. So that's the divide step. Next we do subtract. All right. And now be careful on the subtract step. Be super careful. Super careful. The subtract step is tricky. So I'm subtracting everything down here. You could, if you're careful, try to put a minus sign out here, but be aware that this entire thing is being subtracted. I don't usually write it, but x squared minus x squared is 0. I don't have nothing there. And 6x minus 3x will be 3x. So I'm not adding these, I'm subtracting the 3x as well, right? You could imagine distributing that minus sign if you wanted to think about it that way. So yeah, so subtract everything on the second row from the top row. 6x minus 3x. And then I do what?
Positive 8?
Oh, you got it, dude. You got it, dude. So I get a positive 8 right there. I like it. I like it a lot. So, all right. Let's, what do I just finished one full cycle. Now what do I do? Start over. Let's divide again. What am I going to divide? The leading term by the leading term. Right? Remember when we started over here? I figured out how many times does 6 go into 12 that time, and I wrote my answer up here. Okay? So try to piece this together. You'll actually, once we start going at this fast, you guys will be awesome at this. Let's see. So what's 3x divided by x?
3.
3. And it's positive, so I'll write my answer in the constants column. Notice everybody hanging out in this column, they're all like positive constants. They won't necessarily always be positive, but they're all constants anyway. They're all friends, right? Friendly friends, like terms even. All right, so I got 3. What do I do now? I just finished divide.
You multiply.
Multiply, and I'm going to distribute this 3 by both of those guys and write the answer down here. Okay? So 3 times x is
X2.
3x, right? I'm ignoring that part right now. I'm just distributing the 3. So that's 3x. And 3 times 3 is 9. Positive 9. That was the multiply step. Subtract. 3x minus 3x is 0. I don't have to write it. 8 minus 9. It's not adding. Don't let that trick you. I'm on the subtract step now. 8 minus 9 is negative 1. It turns out negative 1 is my remainder. Yeah, and I know it's weird to have a negative remainder, but be cool. It works. So my answer is x plus 3 with a remainder of negative 1.
So basically, once you plug in the x, you could minus 1 and be done, right?
Almost. Or the other way you could write this is as follows. You could write this as x plus 3 and then plus the remainder over what went under here?
X plus 3.
What did I do here? Where did this go? Oh, the divisor. And the divisor happens, in this case, I got x plus 3 and x plus 3. So the divisor goes here. So I could actually write that as x plus 3 minus 1 over x plus 3 if I wanted. If I wanted to just get that minus sign out, put it out front. So there's two ways that you could write that there. Now, interestingly enough, I can actually do a check on this. Let me show you a quick check. I'm not going to even have you write this down. But the check I'm going to do is I'm going to check to see if this is true. Is the dividend equal to the, well, actually there's a couple ways of writing this. I'm going to multiply the divisor by the quotient. With the remainder in it. All right. The other way you could do this is divisor multiplied by the quotient plus the remainder, which I think is what you were describing there a second ago. And I think that would work out as well. Where I wouldn't multiply the divisor by the remainder as well. So those are two ways I could do this check. So what that's saying is, let's see, am I going to have enough room for that? No, I'm going to go up top here. Yeah, I'm going to go up top. Here's my check continued. All right, so I'm going to have, let's see, x plus 3 was the divisor. Like I said, don't write this part down. And I'm multiplying by the quotient, which was x plus 3, and I'm including the remainder in there. Now check this out. I'm going to do this via distribution. All right, let me pick this color for my arrows. Imagine I multiply this whole thing by all three of these parts. I know this is kind of weird, but I would get the following. X plus 3 times x, I'll just write as x times x plus 3. X plus 3 times 3 would be 3 times x plus 3. And what do I get when I multiply x plus 3 times this fraction? This and this would cancel out. We'll do some more crazy canceling like that later on in this chapter, and I'd have just the negative 1. Okay? So watch, let me do this real quick. X squared plus 3x plus 3x plus 9 minus 1. I'm just distributing out. Combining like terms, I get x squared plus 3x and 3x is 6x. 9 minus 1 is 8. Do we recognize this?
That's the x we got.
This was equal to the dividend.
Exactly.
So that means
That works.
we did it right. Hooray. It's not a very good check mark.
Oh, that's perfect.
There we go. Yeah, I mean, because seriously, you got to ask the question, who checks the checker? Who checks the check mark? You know, like, that's what I just did. Quality control right there. All right. So that, I mean, I just spent a lot of time on that. But I just want to point out it's actually the same exact process. Let's do one other example that's going to expose one potential trick-ish. That's a sad box. There, that one's better. You could live in that box right there. So let's say I want to divide the following. We're going to go through this example quicker since I've explained the process. Now, when I write this set up for long division, let me ask you this question. Let's say I was dividing 12 by 2. Is 12 divided by 2, is that the same as this? No, those aren't the same. Like, those are significantly different. Like, this 0 is important.
Yeah.
Like, if you were getting paid $12 in your paycheck versus 120, you'd tell your boss, like, listen, I actually care about that 0. I know 0 means nothing, but that 0 actually means a little bit to me in my paycheck, right? Versus like that or something, right? Is this the same as this?
No.
No, right? This 0 means something else. It represents a unit in that place, right? There's the ones digit, the tens digit, the hundreds digit. That digit matters, right? What about this?
That's the same.
Those are kind of the same. This one, we don't write the zeros in front. Who cares? We don't care about those zeros. But if they're after our first significant digit, so to speak, we would write them. And this problem, I would argue, needs some sort of a 0 in there. Let me write this up. Let's put the 3x plus 9 as the divisor. And the dividend...
Why is that a divisor?
Well, this is the part I'm dividing by this, so it's the divisor.
Yeah, why would you divide it? Oh, because it says divide.
Yeah, there's a divide there, yep, and divide. So let's see. So the dividend is 6x squared, but I want to point out that I actually have a digit problem here, so to speak. Notice there's no x to the first term here, right? Normally there'd be like a nice little x to the first term there. I need to represent that x to the first in my long division. So I'm going to write plus 0x minus 27.
I'm so confused.
Well, this is called a placeholder.
Why does it even need to be there?
It needs to be there because when I'm doing my work later, I'm going to have columns of work, and I'm going to end up, if I didn't write that, my work gets all crushed together like some sort of Indiana Jones trap, and it wouldn't be pretty. And it's just going to make our work a lot easier, is the only reason that it needs to be there. But that's called a placeholder. And that's the same as if I'm dividing by 602 versus 62. I need that 0 represented there if I actually mean the number 602. So you know that you need placeholders. Basically, whatever your highest degree is, you need to make sure that every degree less than that is represented all the way down to 0, right? x2, 1, 0. All right, so for instance, if this was an x cubed, not only would have I had to have a 0x squared, I'd also would have had to have a 0x to the first.
It's like a perfect backwards
Boy.
5.
Boy, would I really not want to have an x to the 20th or something.
Yeah, that wouldn't be fun. That wouldn't be fun. So let's do this. Divide, multiply, subtract, bring down. Let's cruise through this and bring this video to rest. Here we go. So, divide. Leading term by leading term. 6x squared divided by 3x. Let's see. 6 divided by 3 is 2. X squared divided by x is
X.
x. Where do I write this? Oh, how convenient. I made space for this. All right. Now we're on multiply. That means we're distributing. 2x times 3x is 6x squared. By the way, that should always these two terms should always end up matching after your multiply step. And 2x times 9 is
18x.
18x. And subtract. The 6x squareds cancel out. Hooray! But now question, what's going to go here?
18.
Ooh, we've got a...
Regular 18x.
Oh, wow, we've got a fight. Well, And this, by the way,
Fight you.
on the quiz, I'm going to have a question, a multiple choice question that looks exactly like this, all right?
0.
And I'll have a box here, and I'll say, what goes in the box? And I'll have answers that will say 18x. I'll have an answer that says negative 18x. And I don't have any other good answers in this case because it's a 0. But if this was like another number, I'd have some interesting results. But you need to know what goes there. Now,
It's definitely positive 18.
Okay, Emily.
The 0 is just a placeholder. The 0 is fake.
Emily, just listen. Okay,
But
0
it's
minus 18.
So you
What's
subtract
0?
step.
Okay, everyone, you don't need
All right,
to be
right.
mean.
And no, yeah, we don't want to be mean, but this is actually, subtract step is the trickiest step. Just you be careful there, friends. It's a tricky one. So I'm subtracting this whole thing, so I'm subtracting 18 from 0, and that's why it's negative 18x. Yeah, it's a trickster. And I assure you, many of my students do mix that up throughout the rest of this course. So, but not you guys. You guys will all remember it. You guys are good. You'll remember. So, all right, so I just did one full cycle. Let's divide again. Leading term going into this leading term. So what is negative 18x divided by 3x? Negative 6. The x's cancel out. And I'll write that in the constants column here. And then we'll multiply negative 6 times both of those guys. Keep the sign with it. So negative 6 times 3x is negative 18x. And negative 6 times 9, anyone know?
Oh, negative 18.
Negative
Oh.
54. 6 times 9, 54.
Stopper.
That's all right. And now we're on the subtract step. Okay, here we go. Here's a good question. All right, negative 18x minus a negative 18x. That's the same as plussing it. That's 0, which is what we want. Well, let's see, the real question, what's going to go here?
Negative 27 minus 74 is going to be.
It's going to become plus 54.
Positive 71.
Well, this becomes plus, but then this is negative. I think it's going to be positive 27. Because 54 minus 27, is that not 27? I believe so. But the point is that by subtracting a negative 54, it would have become plus a positive 54. All right? And then the 54 and the 27 had different signs, so I'd subtract those two. I get 27, and it would take the sign of the more influential, which is positive. And that's our remainder. Yeah, so our answer is 2x minus 6 with a remainder of 27. Or, perhaps more interestingly, I could write this as 2x minus 6 plus 27 over the divisor, 3x plus 9. And technically this can reduce a little bit, but I'll let that fly for now. We'll talk more about stuff like that a little bit later. All right, so thanks for watching, Internet friends. Have a great day. Bye-bye.